Okay, good evening everyone. So this is problem number 3 which will be published on 4th September, Wednesday 2024. Okay, so two problems which we have already seen. The first problem which we have seen, if you go back to the videos, you will be able to see is nothing but the first problem was on energy physics, the second problem was on waves, and this problem is on electricity. Okay, let us continue with this. This problem is for 15 marks. Let me try to finish it out within 15 marks, 15 minutes. Okay, so electrical heater consists of two heating elements, E1 and E2. Elements are connected in parallel. Each element has a switch. Okay, there is a switch S1. Where is it? There's a switch S1 and S2 here. Each element has a switch is connected to a supply of 240 volts. Okay, so that means these are parallel. The supply has a negligible internal resistance, no internal resistance. Good. Element E1 is made from a wire that has a cross-sectional area of 6.8 into 10 power minus 8 meter square. So area A1 is given here, and then the resistivity of the wire at operating temperature of the element is 1.1 into 10 power minus 6. Rho 1 is also known to you, and the total length of the wire is 4.5 meters. Length L1 is also known to you. Because why I am taking L1, rho1, A1, because I am talking only about the element E1, right? Then the resistance of the E1 is 73 ohms. The resistance you need to show that. Okay, so don't just say it's equal to 73 ohms. How do you write? So you write R is equal to, let me scroll this a little bit. Okay, so R is equal to rho L divided by A. So what is rho here? Rho is 1.1 into 10 to the power of minus 6 multiplied by length 4.5 divided by area 6.8 into 10 to the power of minus 8, right? All are the SI units, so no need to convert anything. Let me find out where's my calculator. Calculator's here, right? So I'll do this. You can do it using your GDC. So I have 1.1 star 4.5 divided by 6.8. How much is it? 0.727. I just took only the values over here. Okay, 0.727 into 10 to the power of, here you have minus 6, here you have minus 8. When it goes up, it becomes 10 square, which is equal to 72.7 ohms, nearly equal to 73 ohms, right? So we approved the first one. Calculate the output power of E1 with only this element connected to the supply. Only this element connected to supply, which means what? This is open and there's only one resistance over here, which means what? It should have the output power, P output should now be equal to V square by R. Very simple. Only this has been connected. So this should be 240 square divided by 73. What is the value of this? 240 square. So this 240 into 240 divided by 73. So I get the answer 789. 789. What is the unit? 789 watts. So I can nearly put this as around 790 watt. Why? Because you see two significant digits. So here, so everywhere, see here also two significant digits, here also two significant digits. So therefore, the output here is 790 watts, right? Okay, and then next one. Element E2 is made of wire and of the same cross-sectional material as E1. Okay, now we are talking about E2. The length of the wire made is used 1.5 meter. But we'll do one thing. We will first write down what are the values of E1 here. For the E1 value, I had the length to be 4.5 meters. Okay, length L1 to be 4.5 meters. And now your L2, you are saying this as equal to 1.5 meters. Let us read it once again. Made out of the same cross section, which means what? A1 is equal to A2. And material as E1 and same material, which means what? Rho 1 is equal to rho 2, right? Everything is same. Now only length is changing. Length of the wire determines the total power output when both E1 and E2 are connected to the supply. So when E1 and E2 are connected, which means we have one resistance like this, other resistance like this, and then this is connected to in parallel like this, right? Very simple. So therefore, R1 we already know, we already calculated this. How much was it? This was 73 ohms. Now what is R2? You need to find the value of R2. Now towards it, don't waste your time in calculating everything. So now, if L1 was equal to 4.5 meters, R1 was 73. If L2 equal to 1.5 meters, it means 1/3 of it, which means your R2 should be equal to R1 by 3, right? So let us keep it just like this and find out. Now the effective resistance here, effective, when you connect both of them, effective resistance here is nothing but R parallel will be equal to R1 R2 divided by R1 plus R2, which should now be equal to, what is R1? I'll just write R1 multiplied by R2. What is this? R by 3 divided by R plus R by 3. Make it more easier, right? So which should now be equal to R square divided by 3 divided by 4R by 3. This goes away, this goes away. You get the answer as R by 4. Now substitute the value of R. R is equal to 73. 73 divided by 4. What's the value of 73 by 4? Let us do this. 73 divided by 4 should be 18.25. 18.25 ohms, right? So now I don't want resistance, I want the power over here. So now this circuit now becomes something like this. This is your 18.25 and this is your power supply. Power supply was seen to be 240 volt. So what is the power here? I want what is total power? So total power P is equal to 240 square divided by 18.25. When I do this, how much do I get? I get 240 star 240 divided by 18.25. So I get this as 3156 watt. So I get this as 3156 watt, right? So this is the correct answer. So the nearly answer which is given in the answer scheme, okay, is seen to be approximately around 3200 watt, okay, which is the same as here, right? So with this we have completed how much? 1 plus 2, 3 plus 3, 6 mark over here, and we did it for 15 mark, 6 mark. So which means 15 minutes, 15 minus 6 is 7 minutes, 11 or 9 minutes. Okay, we have taken a little bit time. Anyway, I will stop here and continue with the rest of them in the next video. Okay, so let me do the mark breakage for the second one. First one, it's quite easier to understand. Second one, I already told you how do you do it over here. The first mark will be for this one. So calculating this, okay, that is your substituting this value and finally getting this answer. This will be for the second one. And the third one, the mark breakage is like this. So you have it for 3 marks. You are supposed to find out the power. So first one will be to find out what is the new resistance R2. Second one would be to find out, so this is for carrying for 1 mark. Second one would be to find out what is the effective resistance, and the last one is for finding out the final value. Okay, now let me break here, and in the next video you will be seeing the rest of the problems.